Are you an existing or aspiring backend developer that's looking to learn AWS, but you don't know where to start? Now, I don't really blame you. AWS is a super confusing space. There's over 200 different AWS services, and they all do some very specific things. But the good news is that you only really need to know about 20 or so in order to be an effective backend developer. And so that's the general purpose of this video. I wanted to walk through the different themes of AWS services and just introduce you to some of the important ones so that you know they exist and when it makes sense to use one or the other. Now, I'll also add that part of being a good backend developer is just knowing the types of services that exist and the problems that they solve. You don't necessarily need to know about all the details about all of these 20 or so different services, but just knowing what they do and generally when it makes sense to use them is usually good enough, and then you can dive into a specific one if you have a problem that suits that particular service. And so we're going to talk about 6 different themes in this video. We're going to talk about compute, storage, networking, events and orchestration, dev tooling, and then some miscellaneous services. Now, I'm also going to leave a link to this diagram as well if you'd like to access it. I'll also amend this diagram to have hyperlinks to particular videos where I do introductions or just comparisons on many of the different AWS services that we're about to discuss. So without further ado, let's just jump right into it. And first, I want to talk about compute. And we're just going to reveal some of these circles or these squares as we go here. So let's start with compute, and we're going to start with an all-purpose service, which is Elastic Compute Cloud, or EC2. Now, EC2 is one of the oldest AWS services that exists, and it's a pretty familiar model that a lot of you can relate to. It effectively allows you to rent servers from AWS. Now, you're not necessarily renting physical machines, but you're just renting virtual machines. So you can select a particular class of instance, whether or not you want memory optimized, compute optimized, network optimized, a Mac instance, an instance with the GPU if you're doing machine learning. There's a whole bunch of different variations that you can choose from. And there's also a free tier, a micro instance that you can get as part of your first 12 months of your AWS account, where you can use this instance for free. It's not very powerful, but it's enough for you to get started with it. Now, EC2 is kind of like the backbone service of AWS. Pretty much everything else that is built on AWS just runs on servers, right? Nothing is magic. All these different services like databases or caches, they need to run somewhere, right? And EC2 is the backbone of all of it. So a lot of the different services that we'll talk about kind of add additional functionality, but at the end of the day, everything runs on servers, and EC2 is the service that allows you to do that. So there's different payment models that you can use when you're renting a server. You can either buy a longer provision contract, so you can have it for 12 months or so, or you can just do as you go. So you can bring up a server, provided it's available from the AWS data centers, and then you can terminate it and you're not going to be paying a dime more. You're billed by the hour in that case, whereas in the other case, you're billed on a longer time horizon. So that's EC2, one of the primary compute services that's offered by AWS. Now, the next service is a really popular one in modern days, which is in the serverless category, and this is AWS Lambda. And AWS Lambda is getting very, very popular because if you think about EC2 instances, there's a lot of management tasks that you need to do in order to maintain them. You need to worry about security, you need to worry about images, you need to worry about patches, all these different types of things that come with maintaining an EC2 instance. Now with Lambda, a bunch of those problems go away. You no longer need to worry about the instances themselves. You're just worrying about your code that runs on these instances. And for those of you that are familiar with just-in-time compilation, where you compile your code just in time when it's needed, it's a kind of similar model with Lambda. You deploy your code to the Lambda service, and when no requests are coming into your Lambda function, it'll scale it down for you. When lots of requests comes in, Lambda will deploy your code to multiple different instances of EC2 containers, and it will be able to handle much more traffic. So that's the purpose of Lambda. Again, very, very popular, very useful for event processing applications, and also in some cases for APIs. Overall, it's just a lot easier to use versus something like EC2. Okay, so let's move on now, and I want to talk about the different container services that are at your disposal. So where Lambdas are great, like I said, are event processing. APIs, they're kind of finicky because they suffer from a cold start problem. But if you need provisioned infrastructure that exists and is running at all times, there's 2 different flavors that you can use. There's either Elastic Container Service, or ECS, or if you're a Kubernetes fan, Elastic Kubernetes Service. And these allow you to deploy either just ad hoc tasks that are are running on containers. So maybe you need to do a big batch job to process a whole bunch of data for a couple hours or so. And then once it's done, you tear it down. Or if you need to have persistent services, like maybe the backend for a REST API that just sits there waiting for traffic, you can set these up to be in service mode so that you constantly have your infrastructure up and running and waiting to receive traffic. So these are the two main container options that exist for the compute category. Now, another important service that isn't necessarily about compute, but is kind of very tightly connected with a bunch of these different compute services is the next one here, which is API Gateway. And API Gateway is an important service because it allows you to add a layer in front of your compute services. And with this, you can add things like rate limiting, you can add user authentication and authorization, you can provide different client access keys so only certain users can access your backend. It has a whole bunch of bells and whistles for you to define the protocols that are used as part of your API. You can also use it to build WebSockets as well that connect to your backend. So it's a very important service that gets used throughout and allows you to put something in front of your raw infrastructure so that you can do things like metering, rate limiting, traffic shaping, these kinds of things. So a very, very important service that I just wanted to mention really quick. Now, another thing that I do want to call out is things that you shouldn't learn. And these are two AWS services. Elastic Beanstalk is relatively old, whereas AppRunner is relatively new. And these two services are, I'm a little bit hesitant to say not learn them. Maybe you should just learn about what they do and you can decide for yourself. But Elastic Beanstalk is kind of like a wrapper around many different concepts that we already discussed. So you can launch a service and behind the scenes, it'll create an EC2 instance. It'll create an auto scaling group so that you can scale your application. It handles a bunch of the networking things for you too. So really it's just a abstraction layer that sits on top and provides some functionality for you so that you don't need to worry about some of the details. That being said, like this is a super old service. I don't see much support for it. And I think you're better off just to learn about the core concepts as opposed to using these abstraction layers that make it a little bit simpler for you to use and hide the complexity from you. If you need to debug a problem, you're kind of out of luck. The same story for AppRunner. It just makes it easier to run containers. Some things that you'll notice about these like higher level services that offer these types of abstraction is that the price is usually much higher as opposed to using the low-level counterparts. So behind the scenes, Elastic Beanstalk and AppRunner, they're both using EC2 instances. And you can, if you want, build the functionality of Elastic Beanstalk using a combination of EC2 instances and auto-scaling groups and a VPC, which is something we'll talk about later. Okay, so that's it for compute. Let's move on now to storage services here. And with storage services, there are fewer options that are at your disposal, but we're going to start with the simplest one, which is just all-purpose storage, and the service is called Simple Storage Service, or S3. So S3 is great for just general file storage. It's extremely elastic, scalable, and it's great performance as well. So for storing things like images or movie files or text files or your assets for your front end or zip files, basically anything that you want. Your files are organized into things called buckets, and then every item in your bucket has a key, and these are kind of unique identifiers for all your different files. Basically, you can just throw stuff in here for your application. Maybe it's kind of temporary items that you need, or maybe it's more persistent storage, or it could be like audit trails or things like that. There's a whole bunch of reasons where you may want to use S3. Very, very popular to use. It also has triggers that you can set up with it so that if someone uploads or deletes or modifies a file in S3, you can trigger a compute layer. So you can, for instance, if someone adds a file into S3, you can trigger a Lambda function, and that Lambda function will know which file is being referenced, and then you can do things like maybe you want to open it up and examine it or something. So it's definitely one of the top services to know in terms of the storage category. Now, in terms of databases, there are quite a few options depending on what you prefer. So on the relational side of things, there's RDS, or Relational Database Service. This allows you to deploy things like Postgres, MySQL, Microsoft SQL Server, Oracle. There's probably a couple other ones, MariaDB, there you go. There's a couple other ones that exist too, but I just can't recall. But essentially, you can deploy RDS databases and offload some of the maintenance that you would typically have to do yourself. So things like backups, things like scaling, adding reader instances, these kinds of things are made very, very easy using RDS. RDS. Some of you may ask, why should I use RDS as opposed to just getting a EC2 instance and then maybe just loading it with a Postgres database or a Microsoft SQL Server instance or whatever flavor of database that you want. Now you can certainly do that, but if you do that, you're not going to get access to automatic backups. You're not going to get access to auto scaling, a bunch of the different bells and whistles like monitoring and point-in-time recoveries. You're not going to get any of that. So you're going to have to build that yourself, which you certainly can. It's going to be cheaper to go with this approach in terms of direct costs, but in terms of the time that you'll need to put in to ensure that it's up and running and scalable and all that, it's definitely going to be better off to go with RDS. I will also add that they do offer in the relational category a different database called Aurora, and this is kind of a homegrown AWS database that is compatible with both MySQL and Postgres. And it's built, I believe, on top of the Postgres engine, but it adds even more functionality like serverless. So there's a serverless mode that'll auto scale up the instance type. And it also offers a shared data layer as well that's also elastic and auto scalable. So you don't need to worry about running out of space for your instance as well. Aurora is super, super neat. It's kind of the suggested approach, a little bit more expensive than using just default RDS, but in my opinion, very worth it. Now, in terms of the NoSQL side of things, there's three different main options, I would say. There's also some specific use case specific services that you may want to use. I'll mention those briefly as well. So the first one is DocumentDB, and this is just effectively a managed MongoDB cluster. So all the maintenance is handled for you by AWS. You don't need to think about anything. All the data is replicated, everything is persisted. You can recover from certain periods of time. You also have enhanced monitoring as well. So effective for key value lookups for document style databases. And then in addition, you have kind of the bread and butter of AWS's NoSQL land, which is DynamoDB. And DynamoDB is a highly effective NoSQL database that's ideal for key value lookups. It also auto scales, again, has enhanced metrics. This is used extensively within Amazon itself. It also powers other AWS services as well, which is why if DynamoDB happens to go down, a lot of other parts of AWS will also go down. Don't ask me how I know, but it's a very, very popular AWS service, probably one of the most popular if I were to say. And then you have OpenSearch, which is AWS's version of Elasticsearch. Now I put this in NoSQL database category. Now you can use this as a database, but a lot of people use it more for the analytics side of things. So things like Logstash, or if you want to use Kibana to visualize some log data or visualize your data with like histograms or line graphs. It can also be used as a database, although its consistency model is a little bit concerning. So that may be something you want to think about before you choose it as a primary data store. Briefly, I just want to mention some other NoSQL databases that are very use case specific. There's TimeStream, which is more for time series data, high volume time series data. There's QLDB, which is Quantum Ledger Database, which is like for blockchain stuff. I don't know anything about blockchain, but I know that it exists. There's also Neptune DB, which is for graph databases. So if you have a graph data model and you're looking for like a scalable way to perform OLAP or OLTP kind of queries, then Neptune may be a good choice for you to use. Although I believe it uses like a relational database behind the scenes, but you can look into it yourself. Okay, the last category of the storage section is caches. And of course, caches are useful for increasing the performance of any application. So the primary one that you're probably going to be using as a backend developer is Elasticache. And Elasticache is compatible with the two primary variants of caching these days, which is Memcache and Redis. Now it runs in a provision mode, so you need to choose the number of machines that you want to exist within your cluster, but it's pretty straightforward and easy to use. I've used it a bunch of times in different services that I've developed. It's also scalable, easy to add extra nodes. It handles kind of replacing nodes in case there's failures as well. So overall, a really, really great service. Now, the other one is CloudFront. Now, this is more on the asset serving side of things. You're not necessarily going to use CloudFront at the application level. This is more for caching like resources that are repetitively accessed in order to improve performance where you have users that are on different parts of the world or located in different parts of the world. So the typical way that you use CloudFront is you combine it with S3. So like when a user tries to, if I can get like an arrow, like a user tries to access a URL, they'll be directed to the CloudFront distribution. And then if the item is not in the cache in CloudFront, it'll retrieve the item from S3, so simple storage service. So your S3 will be the primary where the source of the data is, and then CloudFront will be the cache where it's located and copied and persisted into different data centers across the world in order to improve performance. So that's what CloudFront is. More useful for, I would say, full stack developers and front-end developers, but it's good to just know about what it is in order to be well informed. Okay, cool. Let's move on now and talk about networking. And networking is kind of one of the worst parts about AWS, in my opinion. It's where I struggled the most personally, but I hope I can demystify some things for you. Now, some of you that work in companies that have some DevOps people or some network engineers may need to worry about this less, but there are some important concepts that you need to know about that if you don't know about are going to make your life extremely frustrating. And I'm going to try and highlight them for you here. So the first one in terms of networking is virtual private cloud. And I realize I'm missing a thing here, which is going to bother me. Okay, and it's VPC, virtual private cloud. And the idea with VPCs is that it's kind of like an isolated location within the AWS cloud where you have access to your private network. So it's very similar to what I have or what you have on your home network, right? You have a home network with people connecting to Wi-Fi. They have their own private IP addresses. It's exactly the same thing in the AWS cloud. So it's great because it allows you to isolate yourself from other users of AWS, and it kind of lets you lock down your data so that no one can access it, and only those that you give explicit permissions to, both at the permissions layer, which I'll talk about later, and at the networking layer, can access your services. So VPC is kind of like an umbrella service that has a bunch of different concepts within it, but some of those important concepts are as follows. So let's talk about them briefly. The first one is subnets. So if you're a networking guy, you already know all about this. There's public and private subnets. Public subnets are where you put your user-facing infrastructure, so stuff that you want exposed to the public internet. So things like your REST API backend, for example. Private subnets are for things where you want to hide from the public internet, so you don't want to have a public IP address associated with them. Things like databases, things like, analytics servers or data engineering stuff or Redshift cluster, stuff where you just basically want to be private and no one can see except people that are internal. You put that in a private subnet. And now you also need to know about route tables, and route tables kind of define the rules, the communication rules between the different resources that are in your VPC. So you can say all instances can talk to all other instances in the subnet, or you can define specific rules to restrict things. There's a whole bunch of stuff that you can do with route tables to basically control the flow of traffic in your VPC. And then there's also security group, which is probably the one that most people get confused about and the one that often causes the most problems with people trying to learn and use AWS. And I just want to draw a quick picture about security groups because I find that, it is the most confusing part, and I feel like it warrants a picture. And so what a security group essentially is like a firewall. And the thing that makes it confusing is that you attach it to a piece of infrastructure. So like a Lambda function or an EC2 instance or a database or a load balancer, it gets attached to pieces or components of AWS. And so what happens is, so let's say we have an EC2 instance. Ooh, that's a lot darker. Okay, say we have an EC2 instance here, right? And then we have an RDS database down here. Okay, and these both exist within your VPC. Imagine there's a big box around them. So they're in your VPC. Now, say you have like the route table set up where, these things are allowed to talk to each other. You also have them in the correct subnets. You have your EC2 maybe in a public subnet and your RDS in a private subnet. What happens is that out of the box, these two things are not going to be able to talk to each other. And the reason is that the security groups need to be set up in a way that give permissions for the EC2 instance and the RDS database to talk to each other. So essentially, a security group, when you create the EC2 instance, I'll just kind of put like a little box here. This is the security group of that instance. And this is a different security group of your RDS instance. You need to give explicit permission in both directions. So from this perspective, from the perspective of the EC2 security group, you need to say that I am willing to receive inbound traffic from this security group that belongs to the RDS instance, right? And conversely, you need to say the same thing in the opposite direction. So the RDS instances security group needs to give permission to the EC2 security group in order for it to receive inbound traffic. And so there's inbound and outbound rules. So you need to say what I'm allowed to talk to and what I'm allowed to receive traffic from. And so it's kind of like a mutual agreement. I'm allowed to talk to you, you're allowed to talk to me. And so people get very lost with security groups. Now, another thing is that security groups, they're kind of like named objects, and you can like name them like SG1, for example. And, it has the ability to receive traffic from RDS and vice versa. If you have another EC2 instance, you can attach it to that instance. So you could put like SG1. And if you do, then it's going to have the same permissions that we just drew over here. So like this. So that's a little bit about security groups. Like, you're going to get lost with these from time to time, but this is the principle about how they work. And so I just wanted to call that out so that you understand. So let me try and erase all this stuff now. If there's an easier way, I don't know, but we're getting there. We're almost there. Okay. All right. So let's move on now with networking. Now, two other important things to know about are in the kind of website or DNS management category. So there's Route 53, and this is the service where you register your domain name, you register your traffic policies if you want geographic traffic policies or weight-based trafficking, or you want to redirect traffic or create CNAMEs or aliases, things like that. That's all done in Route 53. And then if you want to attach certificates to enable HTTPS, then you would do that in AWS Certificate Manager. Okay, so that is it for networking. Let's move on now to events and orchestration down here. And this one is important for backend developers that want to communicate with other AWS services in an asynchronous manner. Asynchronous mean like you fire a message out, you don't necessarily know who it's going to, but someone on the other end is going to receive it. And so the popular model for events is the pub/sub model. So there's a publisher and a subscriber. And so there's three main services actually. Let's talk about them one by one. So the first one is Simple Notification Service, or SNS. And this service is another really, really old one, same as this one down here, Simple Queue Service. But SNS is the publisher. So as a user, if I get my pen back, you publish a message to your SNS topic. And then depending on who is subscribed to that topic, you can have a EC2 instance subscribed, you can have a SQSQ subscribed, you can have a whole bunch of different protocols that are subscribed. SNS will deliver that message to each of these different subscribers, right? So one message in and messages out, right? And so this is the publish service. So it allows you to publish messages to it and send it to all your different subscribers. Now, you also have EventBridge, which is more of kind of like an event bus. And so folks will publish a message with a particular payload to an EventBridge event bus. And then you can define these like rules. And if the message contents match a particular rule pattern, then it'll be delivered to like a certain location, right? And if it matches a different rule pattern, it'll be delivered to a separate location. And so this is kind of the main purpose of EventBridge. You publish to the bus and you have these rules that specify the routing of your messages. Very, very useful. And it also emits events for popular kind of administrative events in your AWS account. So when EC2 instances come up or come down or get terminated, or certain things like administrative stuff happens in your account, that all can get broadcasted to an EventBridge event bus. Now, the other important thing is this kind of clock thing that I have over here. And the reason that I put this is because EventBridge also has the ability to create timers. And timers are very, very useful, either recurring timers like a cron job, so do everything, or trigger an event every hour, for example, or every other day on midnight. I don't know, if you want to do some kind of a min job. So that's one use case, kind of recurring events. They also have single instance events. So say you have an application, for example, where someone signs up for your application and you want to send them an email in 7 days. What you can do is when someone signs up, you can create an instance of an event to fire in 7 days from now, and then have a listener to that event to say, okay, when that event fires, I'm going to do something, maybe send them a reminder email, something like that. That's also supported in EventBridge. This is EventBridge Scheduler. So you can look into that service. It's very, very powerful. Okay, so that's it for EventBridge. Let's talk about Simple Queue Service. And so Simple Queue Service is kind of what the name would imply. So it's a queuing service and allows users to send messages to this queue. And these messages will stack up. So, with 3 arrows, we have 3 messages in this queue. And then you can have a consumer that sits on the other side here that is pulling messages off of this queue and processing them, right? So it's pulling off, processing them, pulling off, processing them, pulling off, processing them. And in this kind of mystery box here, you can put in there's a broad variety of services you can put in here. You can put in like a Lambda function if you want that'll directly connect to your queue. You can create an EC2 instance that will pull the queue. You can create an ECS service that will pull the queue. Doesn't really matter as long as you're conforming to the API. However, with Lambda, this is super, super simple. You just connect these 2 things together and it works pretty much out of the box. Now, a very common pattern that you'll see over and over again is the combination of SNS and SQS. So you'll have one set of users or one service that is broadcasting to an SNS topic, and then you'll have a bunch of SQS queues that may belong to different AWS services, not AWS services, but different service teams that are all listening to this event, right? So they're listening to this event. And then you have different infrastructure pieces that are consuming those messages. And so this is a team, this is a separate team, this is a separate team. And so you'll see this very often in service-oriented architecture organizations where, you have an event like a customer places an order. That's a very popular event that a lot of different teams may want to know about. And so that's where something like SNS is perfect for. So that is the PubSub stuff. Again, let me try and erase this if I can, see how far back the history goes here. Wow, okay, perfect. All right, so let's move on now from PubSub and talk about a couple other ones here. The next one is Kinesis. Now, Kinesis is similar to some of these, but it's more for data processing in a massive, massive volume, more on the data side of things. So think about clickstream events coming from a UI, every time someone hovers over something or clicks a button, you want to consume that. Or real-time location movements of devices that are deployed in the field where you can have tens of thousands of them. This is what you would use Kinesis for. And it's very useful because, there's a bunch of different umbrella services within Kinesis. There's Kinesis Analytics, which is more for analyzing data and joining it and grouping it in real time. Then there's Kinesis Data Streams, which are just meant for data capture. And you can have multiple different subscribers that can read off of the stream at their own pace. And then you have Kinesis Firehose, which is for batching data and delivering them in chunks. And so it's a very versatile service that allows you to capture tons and tons and tons of data at a ridiculous scale, and you can scale it up pretty much as high as you want. So it's useful in this data capture scenario and processing, but it's not necessarily the most important for a typical backend developer, but again, it depends on your product space. Okay, the last one for events I wanted to talk about was in terms of workflows. And this is actually one of my favorite AWS services, which is AWS Step Functions. It replaced a previous service, which is called AWS SWF or Simple Workflow Service. But Step Functions allow you to create workflows and coordination between different AWS services. So say, for example, someone signs up for a service, signs up for your product. You want to trigger a sequence of things, right? You want to send an email to them, then you want to save something to a database, then you want to run their credit card through some kind of fraud detection service, and depending on the result, you save something else to the database. If you were to do this in a very linear way, like in an EC2 instance as part of one function, there's partial failure scenarios that can make this very, very complicated to recover from. But if you're using step functions, they allow you to use this really neat kind of drag and drop interface where you can say, okay, first step, I want to do this, integrate with this service, this API. Second step, I want to execute this Lambda function. Third step, I want to save to a database. Fourth step, I want to do this. It's also got retries built in and a really neat monitoring dashboard where you can see the state of your application or the state of your workflow over time. So very, very, very useful for a lot of different applications that require distributed coordination at scale. I also have a course on this service, Step Functions Masterclass, which I put a lot of time in, and it's meant to teach you pretty much everything you need to know if you want to use workflows and step functions in AWS. So I'll put a link to it somewhere here, either in this sheet or in the description section, or you can just Google it. It's called AWS Step Functions Masterclass. Okay, cool. So that's it for workflows. Let's move on now and talk about some dev tooling. And this one's a little bit brief. So the first one is infrastructure as code. Most of you probably already know what this is. It's when you want to create your code not manually through the console, but using infrastructure. There's two main options that you should consider using. The first one is CloudFormation. CloudFormation requires you, it's more imperative. So you define a template file that says what you want. And these template files can be typically very, very large and have, I've seen some that are thousands of lines if you have a lot of infrastructure that you need to create. Not the most easy to organize and understand. They're very verbose. The autocomplete features that exist as well as part of like IDEs isn't really there. So you'll find yourself kind of looking at the AWS documentation, trying to figure out, what is the right parameter for this? Also, the errors aren't very useful as well. But CloudFormation essentially allows you to create these templates and then upload it to AWS, and then they will take this template and create all the infrastructure that you've defined within it for you in a workflow style application. It actually probably uses like step functions behind the scenes now that I think about it. But that's CloudFormation. And if you like a imperative style, wait, did I say this one was imperative? Sorry, CloudFormation is declarative. So you declare how you want your output to be. I always get confused with these two for some reason. Cloud Development Kit or CDK is imperative. So what CDK allows you to do is it allows you to write code that defines your infrastructure. So you can like create these things called constructs. Some of them are provided by AWS. Some of them you can write yourself. You can use things like for loops and if statements, these kinds of things. This is by far the like suggested approach to use if you are using infrastructure as code. Now, these are kind of the homegrown services that you would use if you want to go all in on AWS. You can also use things like Terraform or Pulumi or other external services as well, but these are kind of the native supported ones. And next, there is just some more tooling that's useful, which is the AWS Toolkit. This is a component that you can add to your IDE, and it makes it just very, very easy to explore AWS resources directly in your IDE. So I'm a big Visual Studio or IntelliJ user. And so there's the AWS Toolkit is offered for both of those. So you can install it, you just configure it. It's very, very simple. It's part of like the extensions part of your IDE. And then you can directly like see what's in your database, for example, your DynamoDB database, just using the toolkit and right clicking some things. Also allows you to like create infrastructure really, really quick, just using the toolkit as opposed to going into your browser and doing it yourself. So just some shorthands to make it easier to. Also lets you look at logs directly in your IDE. So a bunch of things that make your life easier. Now, the last category is just general miscellaneous stuff. These are just some things that you should also know about. So the first one, this one is definitely something worth knowing a lot about, which is Identity and Access Management, or IAM. And this is the service that effectively allows you to say what has permissions to talk to what at it's the authorization service effectively. And so there's different entities, there's users, there's roles, there's groups. Typically you'll be working with users or roles. Users are like physical things or physical people. Roles are like, a student or a teacher or a supervisor. They're kind of like personas. And so you can define permission templates that are associated with either a role or a user. And these permission templates are things like DynamoDB put item or S3 get object or SNS publish. They're very explicit and they boil down to the exact API actions for each of the different AWS services. And you can bundle a bunch of these together in a permissions template and then associate it with a particular user or a particular role. So you're going to be working with IAM quite a bit. So it's important to know what it does and what it is. Definitely like watch a video or two on IAM. The next one is important as well. It's in terms of monitoring, and that is Amazon CloudWatch. And CloudWatch, effectively, there's two main important, or maybe three important areas here. The first one is logs. This is where all the logs go in terms of your application. And so if you're using something like a Lambda function and you do like a console.log, your logs are going to go to CloudWatch in a log stream. Also for things like ECS or EKS, you can propagate the logs on the ECS containers or the EKS containers into CloudWatch CloudWatch so you can analyze them. Now, the other thing to know about CloudWatch is that there's also alarms and metrics. So you can look at different metrics over time. So things like CPU utilization, things like concurrency or memory usage, these kinds of things. You can also define your own metrics, like business metrics in your application. And so if you have like an if statement and like, okay, if the customer places an order, and it can either be a purchase or a refund, and you want to know how many times it's a purchase, how many times it's an order or a refund, you can add a metric for the purchase case, a separate metric for the refund case, and then maybe look at a cool dashboard that shows you kind of the delta between them, or just the flow of purchases and refunds over time. And that kind of leads me into the next one quite nicely, which is alarms. So you can set up alarms on these different metrics. So if they go above a certain threshold within a certain time range, you can trigger an alarm, and you can get like paged on your phone. You can get text messaging. You can integrate with Datadog, which is a popular paging service, or not Datadog, sorry, PagerDuty, that's the one. So very, very powerful. And the last important feature of CloudWatch is dashboard. So you can create like collections of graphs that you throw on a dashboard. And then when you go to this dashboard, everything is right in front of you with regards to a specific application. And you can basically just figure out what's wrong just by glancing at this one dashboard. So very, very helpful, very, very popular. The last service is in terms of authentication and authorization, and it's called AWS or Amazon Cognito. And Cognito effectively provides you with a UI that you can integrate with your application on the front end, and you create like these user pools that are like the collections of users that exist on your backend, and it manages things like usernames and passwords, integration with other providers like Google or Facebook, or login with Facebook, or login with Amazon, these other kinds of things. And it handles all of the coordination for you. So you don't need to store your passwords in plain text, right? And Cognito just does it for you. And so these are the core AWS services that I think need to know about as a backend developer. And at this point, you're probably wondering like, okay, this is great, but like, how do I get started now? The advised way that I would suggest is doing projects. You can certainly do an AWS certification, but in my opinion, certifications don't really teach you practical skills. So maybe something that you can do, like we can like draw this out really quick. Maybe you can build like an image processing application. So you'll want like an API gateway for your front end to have your REST API. You can connect it to a Lambda function that's going to serve the requests. And then if someone wants to like process images, first you upload them into S3 to store them. And then you store a reference to that key that you put in S3 into DynamoDB, or like an RDS instance or something like that. And then maybe you like trigger a workflow, which is down here, to do a bunch of things, and then you kind of monitor it all in CloudWatch, something like that. So there's like a whole bunch of different things that you can do here. I do have a course, by the way, called the AWS Learning Accelerator that kind of does something a little bit similar. It uses machine learning or Amazon recognition for facial feature detection. It's kind of a full stack app that uses Lambda, API Gateway, S3, Amazon recognition, SNS, IAM, cloud. It actually uses like a lot of the ones here. So that's another way to do it too, is by like doing guided courses. But yeah, this is kind of my introduction for backend developers and the top services that you need to know. If you have any questions or concerns, let me know in the comments. I'll try to respond. And thanks so much for watching. I will see you in the next one.